Hello everyone. I am going to start with components of Azure Databricks. Workspace. The workspace in Azure Databricks is a collaborative environment where users can organize and manage their Databricks assets such as notebooks, libraries, experiments, and dashboards. It acts as the central hub for users to work together on data projects. Folders. Organize your work into folders. You can create nested folders to manage projects and resources effectively. Notebooks. Interactive documents that contain executable code, visualizations, and markdown text. Notebooks can be written in multiple languages such as Python, Scala, SQL, and R. Libraries, reusable pieces of code, such as Python or Scala libraries, that can be imported and used across notebooks. Recents. The Recents section in Azure Databricks helps users quickly access their recently used resources. This includes recent notebooks, a list of notebooks that you have recently accessed or modified. Recent files, recently used files within the workspace. Recent jobs, recently run jobs or workflows, making it easier to rerun or review them. This section improves productivity by providing quick access to frequently used items, saving time spent on navigation. Catalog. The catalog in Azure Databricks refers to the metadata management and data governance capabilities. It helps manage and organize data assets. Databases and tables. Organize your data into databases and tables. This provides a structured way to store and manage data. Schemas. Define the structure of your data, including tables, columns, and data types. Data governance. Implement policies and controls to manage data access, compliance, and security. This ensures that data is used appropriately and securely within the organization. Delta Lake, a storage layer that brings ACID transactions and scalable metadata handling to big data workloads. Delta Lake is often used within the catalog to manage data reliability and integrity. Workflows. Workflows in Azure Databricks refer to the orchestration and automation of data processing tasks. This includes jobs. Automate the execution of notebooks, jars, or Python scripts. Jobs can be scheduled to run at specific intervals or triggered by events. Tasks. Individual steps within a job. Each task can run a different notebook or script. Dependencies. Define the order in which tasks should run, allowing for complex workflows with dependencies between tasks. Monitoring and alerts. Track the status of jobs and receive notifications for successes, failures, or other significant events. Workflows ensure that data pipelines and processes run reliably and efficiently, reducing the need for manual intervention. Compute. Resources used to run your data processing and machine learning workloads. This includes clusters, groups of virtual machines, VMS, that Azure Databricks uses to execute code. Interactive clusters, used for development and interactive analysis. These clusters can be manually started and stopped as needed. Job clusters, automatically created for running scheduled jobs and terminated when the job is complete. These are optimized for cost and efficiency. High concurrency clusters, designed for concurrent workloads, providing better resource sharing and isolation for multiple users. Cluster configuration, customize clusters by selecting VM types, auto-scaling settings, and attaching libraries. You can configure clusters for different workloads and performance requirements. Pools of idle instances that can be used to reduce the startup time of clusters. By maintaining a pool of ready-to-use instances, you can quickly scale your computational resources. Then SQL part. SQL Editor. The SQL Editor in Azure Databricks is an interactive interface where users can write, edit, and execute SQL queries. It provides a user-friendly environment with features such as syntax highlighting, autocomplete, and query execution buttons. The SQL Editor allows users to interact directly with their data stored in Databricks managed tables, Delta Lake, or other connected data sources. Queries. Queries in Azure Databricks refer to the SQL statements written and executed within the SQL Editor or notebooks. These queries can be used to retrieve data from tables, perform data transformations and aggregations, join multiple data sets, filter and sort data based on specific criteria, create and manage views, stored procedures, and functions. Queries can be saved, shared, and reused, facilitating collaboration among team members. Dashboards. Dashboards in Azure Databricks are interactive visual displays created from the results of SQL queries. They allow users to present data insights and metrics in a visually appealing format. Key features include widgets, visual elements such as charts, graphs, and tables that display query results. Interactivity, filters and input controls that allow users to interact with the data and dynamically update the visualizations. Sharing. Dashboards can be shared with other users or published for broader access, making them useful for reporting and business intelligence purposes. Alerts. Alerts in Azure Databricks are notifications triggered by specific conditions in SQL query results. They help users monitor key metrics and thresholds, and can be configured to send notifications via email or other communication channels when certain conditions are met. For example, an alert can be set to notify a user when a value in a table exceeds a predefined limit. Query history. Query history in Azure Databricks keeps a record of all SQL queries executed by a user. This feature provides audit trail, a comprehensive log of all queries, helping users track their activities and changes made to the data. Reusability, users can revisit and rerun past queries, saving time and effort in rewriting SQL statements. Troubleshooting, access to historical queries assists in debugging and understanding previous data manipulations. SQL Warehouse. SQL Warehouse in Azure. Databricks, often referred to as Databricks SQL Warehouse, is a managed compute resource that scales to support data warehousing and high-performance SQL workloads. Key aspects include scalability, automatically scales up or down based on the workload, ensuring optimal performance and cost efficiency. Performance, optimized for SQL workloads with features like caching and indexing to speed up query execution. Integration, seamlessly integrates with other Azure services and data sources, allowing users to query data stored in Azure Data Lake Storage, Azure Blob Storage, and more. Security, offers enterprise-grade security features, including data encryption, role-based access control, and compliance with industry standards. Then next part, data engineering. Job runs. Job runs in Azure Databricks refer to the execution of scheduled jobs. Jobs in Databricks automate the process of running notebooks, jars, Python scripts, or other tasks. Key features of job runs include scheduled execution. Jobs can be scheduled to run at specific intervals, example hourly, daily, or triggered by certain events. Task dependencies, define the sequence in which tasks within a job run. This allows for complex workflows where one task depends on the completion of another. Monitoring and alerts, provides monitoring of job runs, logging of execution details, and setting up alerts for success, failure, or specific conditions. Retries and fault tolerance, configure jobs to retry failed tasks and handle transient issues gracefully. Parameterized jobs, jobs can accept parameters, making them flexible and reusable for different scenarios. Data ingestion. Data ingestion in Azure Databricks refers to the process of importing data from various sources into the Databricks environment for processing and analysis. Data ingestion can be done using several methods. Azure Data Factory, ADF. ADF can orchestrate and automate data movement from various on-premises and cloud sources to Databricks. It supports scheduling and complex ETL workflows. Databricks Notebooks. Notebooks can be used to write custom ingestion logic using Spark, allowing you to read from multiple data sources like Azure Blob Storage, Azure Data Lake Storage, ADLS, and databases. Autoloader, a feature that incrementally and efficiently processes new data files as they arrive in cloud storage. It automatically detects and processes new data files. APIs and SDKs. Databricks provides APIs and SDKs to programmatically load data into Databricks from various sources. Delta Live Tables. Delta Live Tables, DLT, in Azure Databricks is an advanced data engineering tool that simplifies the creation and management of reliable data pipelines. It builds on the capabilities of Delta Lake, providing a declarative framework for defining data transformations. Declarative pipelines define data transformations in a declarative manner using SQL or Python. Specify what the transformation should accomplish, and DLT handles the underlying execution. Automatic management, manages the underlying infrastructure for data ingestion, transformation, and storage, reducing the operational overhead. Data quality. Incorporate data quality rules directly into the pipeline to ensure data correctness and completeness. Versioning and lineage. Automatically tracks the versions of your tables and the lineage of your data, making it easy to audit and understand the data flow. Optimized for Delta Lake. Leverages Delta Lake's features like ACID transactions, scalable metadata handling, and unified batch and streaming data processing. Next part: machine learning. Playground. The playground in Azure Databricks refers to the interactive and exploratory environment where data scientists and analysts can experiment with data, develop models, and test new ideas. Key characteristics include interactive notebooks. Users can write and execute code in an interactive manner using notebooks. Notebooks support multiple languages, including Python, Scala, SQL, and R. Visualization tools. Integrated visualization libraries allow users to create charts, graphs, and dashboards to explore data insights. Visual changes and discussions. And the ability to query and manipulate data in real time. Experiments. Experiments in Azure Databricks refer to the process of tracking and managing machine learning experiments. This involves keeping records of different model training runs, parameters, and results. Key components include MLflow tracking. Azure Databricks integrates with MLflow to track experiments. Users can log metrics, parameters, and models. Experiment runs. Each training session or model training attempt is recorded as an individual run, capturing details such as algorithm used, hyperparameters, training time, and performance metrics. Comparison and analysis. Tools to compare different runs and analyze their performance to identify the best models. Features. Features in the context of machine learning in Azure Databricks refer to the variables or attributes used to train machine learning models. Feature engineering involves creating new features or transforming existing ones to improve model performance. Key aspects include Feature Store, a centralized repository to store and manage features. It ensures that features are reusable, shareable, and consistently used across different models. Feature engineering, the process of creating new features from raw data using various transformations and aggregations. Feature selection, identifying the most relevant features for a model to enhance its performance and reduce overfitting. Models. Models in Azure Databricks represent the machine learning models developed, trained, and stored within the platform. Key features include model training, using notebooks and automated jobs to train machine learning models with various algorithms and data. Model management, versioning and managing different iterations of models. This includes tracking the performance and metadata of each model version. Model Registry, a centralized place to register models. The MLflow Model Registry in Azure Databricks allows users to manage the full life cycle of ML models, including model versioning, stage transitions, example staging to production, and annotations. Serving. Serving in Azure Databricks refers to deploying machine learning models to production for real-time or batch predictions. Key components include model deployment. Deploy models from the model registry to production environments. Real-time serving, using APIs to serve models for real-time predictions. Databricks allows deploying models as RESTful endpoints for low-latency predictions. Batch inference, running batch predictions on large datasets using Databricks clusters. This is useful for scenarios where predictions need to be made on a large number of records at once. Monitoring and scaling, tools to monitor the performance of deployed models and scale the infrastructure based on the load and requirements. Next, Marketplace and Partner Connect. Marketplace provides access to third-party tools and data sets. Simplifies purchasing and deploying additional resources. Enhances the functionality of Databricks with a variety of solutions. Partner Connect simplifies the integration. Data ingestion. Data from various sources, IoT devices, application logs, etc., is ingested using Azure Event Hubs or Azure IoT Hub. The ingested data is stored in Azure Data Lake Storage, ADLS, or Azure Blob Storage for raw data storage. Data processing. Azure Databricks reads the raw data from ADLS and Blob storage. Data engineers use Databricks notebooks to clean, transform, and process the data using Spark. Processed data is written back to ADLS or stored in structured formats in Azure SQL Data Warehouse or Azure Cosmos DB. Machine learning. Data scientists use Azure Databricks to build and train machine learning models using libraries such as TensorFlow, PyTorch, or MLib. Trained models are deployed and managed using Azure Machine Learning Services. Data visualization and reporting. Business analysts use Power BI or Azure Synapse Analytics to visualize the processed data. Real-time dashboards and reports are created to provide insights and drive business decisions. CI/CD and monitoring. Azure DevOps integrates with Azure Databricks to enable continuous integration and continuous deployment, CI/CD, pipelines. Monitoring and alerting are set up using Azure Monitor to track the health and performance of Databricks jobs and clusters.